In this video, we're going to use a normal distribution to convert from a percentage or a probability to an X value. So 2 videos ago, we learned about some normal distribution concepts. The last video, we learned how to go from an X value to a percentage. This time, we're going to go from a percentage to an X value. So in the example in the first video, for example 2, we talked about we want to mail a special brochure to our customers in the top 20% of the amount of sales that they purchase. So again, as a sales rep, I want to target this group and be able to work with them. Now, there are other ways to do that if you use percentiles and other things, but using the normal distribution when you know the mean and the standard deviation gives us another way to look at it, and it's not based off of a sample, it's based off of population data then. So again, we have XYZ production plants. They studied their sales per customer. And when you look at the bell-shaped curve below, it appears to be bell-shaped, not exactly bell-shaped, but mostly bell-shaped. The average sales per customer is 23,420, and it has a standard deviation of 3,281. So we're going to pull from that we know we can use a normal distribution. We have a mean of 23,420 and a standard deviation of 3,281. So let's go ahead and work this problem. Again, I'm going to be using Excel and Paint so that you can see what we're doing as we go through. So I pulled the key information, normally distributed, standard deviation, and mean, the event of interest. What is the sales dollars associated with the top 20%, which was the problem that we're working on. So how do we go ahead and graph this? Well, we know that we want the top 20%. So the top 20%, remember that percentage is always in this top area under the curve. The top 20% is going to be somewhere in here. So if we take this and we fill in our top 20%. Now, if we had just been given the equation here, we would have known that it was a right tail, the arrow is pointing to the right, and we would be filling in 20%. So we know that this value right there is 0.200. Let's go ahead and change that to black again. So now that we know that that area is 0.200, we need to be able to work our way backwards. So we're, again, like the last example, we're going to take our table method or our charts where you can look up values of z-scores. And so we're going to convert from a percentage value down to a z value, and then take a second step of a z to an x value. So we're just going to concentrate right now on the z to the percentage to z at the moment. So using the chart method, what you're going to need to do is we need to figure out what values go with the rest of these probabilities. So the probability of this area is 0.500, right? So 50% is on each side. If I know 50% is on each side, I know this is 50 and this is 20. That gives me 70%. It means that this has to be 30%. So when I look to figure out what I'm going to look at in the back of the book, we are going to look at, because the area in the back of the book always goes between here and there. So we're going to look at that area in there. So between the 0 mark for your z-score and your value. In this case, we know the percentage value, but we don't know the z-score. So remember that z-scores are on the outside, percentage values are in the middle. Since we know the percentage value is 0.300, we're going to look at the inside of the chart for 0.300. Now it starts at 0 there and goes to 0.4990 here. So 0.300, I cross this threshold here, so I'm going to go up. So I'm between 30% is somewhere between these two values here. It is closer to this one. So my z-score, if we read the outside now, is a 0.84. So the z-score associated with the 30% in this section in here is 0.84. So we took a percentage value of 0.300 because that's the way our charts looked at, and we found that the z-value associated with that was 0.84. Next, we're going to convert the z-value to an x-value. So converting from z to x, we're going to use z is x minus our mean divided by our standard deviation. We're going to use the same formula we did the last time. In this case, we know that it is going to 0.84 equals something we don't know minus our mean, so that's going to be 23,420 divided by our standard deviation was 3,281. Now if you solve that using regular algebra, you're going to multiply both sides by 3,281, so we're going to multiply 0.84 times 3,281. And since we're going to want to get x by itself, we're going to do the opposite of subtract because that's there. So we're going to add 23,420. And we're going to come up with 2,600 or 26,176. Now, does that make sense? Well, we said that our mean value was 23,420. So is that larger than 26,176? So our value for our z-score and for our top 20% is 2,600 or 26,176. So our answer to that is basically going to be the top 20% of sales belong to those who purchase more than $26,176 in sales. As the manager, then now I have my choice, or the sales rep. Do I want to just cut that off at 26,000? Now keep in mind, if you do that, you're going to get more than 20%. So you can be exact with the number, or you can work with it in there. If you have some really good clients that are in this area and your manager is okay with you going a little above 20%, you'd be able to include those in there. But if you were going strictly by 20%, you'd use this value here. Now, how do we do this using the percentage value, or using the Excel method? So the Excel method is actually much, much easier than this one. You don't have to worry about this conversion of the z-score or anything. It is simply just using a formula. So the formula that we're going to use is one that's equals norm.inv. So it's a normal distribution that we're working with, so that's where the norm is. The .inv is because we're going from a percentage value to an x value. So we're going to use .inv. The first thing it asks for is a probability, so we know that, we have to figure out what probability goes in there, don't we? So I'm going to go ahead and take a back step on this one. So in Excel, when we do this, it always calculates the percentage value from negative infinity up to the point of interest. So in this scenario, we're looking here. So what is the probability from 0 up to here? Could have done it one of several ways. We knew that this was 20%. So using the rule of inverse on there, we could have said, well, 1 minus 20% is going to give us 80%. And so let's go ahead and equals norm.inv. So now I know the percentage value I have to put in there is 0.8, or I could go ahead and put 80%. I know that my mean, which is what it's asking for next, is 23,420. I know my comma, my standard deviation is 3,281. And I'm going to end parenthesis on that one. And when I do it, it comes up with the answer of 26,181. So when I do this, the top 20% of sales belong to those who purchase more than $26,181. Now notice there's a slight difference between these two. We have a difference of what, $5 between them. It has to do with the fact that the chart in the back of the book, we had to go with the 0.84 was the closest z-score. Using the Excel method, it is the exact area under the curve. Now again, using this methodology, there's a little bit of fudge room in it anyway, so my response to that would probably be, as the sales manager or the sales rep, I would pick 26,180 as that number and work from there. And that way, in this scenario, I'm going to get a little less than 20% that I'm going to send a special brochure with a special purchase offer on. There's going to be two more videos. One going from percentage to z-score and another one going from z to percentage. So the last two videos covered the percentage to x's and x's to percentages. So we're just going to be looking at some different ones in the next two videos.